Hi and welcome to my mess. I bought myself a DIN rail power meter, AC DIN rail meter. It shows voltage, current, power. Which kind of power I don't know yet. Is it real power, apparent power, reactive power, energy consumption. Looks like this. Here you connect live and neutral. Let me just focus on it a little bit. Here you pass the wire with current because it's a current transformer, and I want to do a couple of tests with it. First, I want to check if the voltage it shows is close to what another meter shows. This one, I trust it a little more. Then I want to check if the current is okay as well. Then I want to check what happens if I introduce a phase shift between voltage and current, because well, it measures voltage, it measures current. What if it just multiplies the voltage by current? We will get an apparent power. I don't want to get into the differences between those three power types. There are other videos on YouTube that probably do it better than I do. Just know that the real power is what is the power that you actually pay for. And there can be also a reactive power, which is something that doesn't do any work in your house, but just hits the wires by the current flowing back and forth. And there is an apparent power, which is a product of some sort of those two. And if you have a resistive load, you have only a real power. But if you have a reactive load, so a capacitor or an inductor, then you have a phase shift between current and voltage. And then, for example, you can have a maximum current when there is no voltage. It's hard to explain really, and I don't want to get into details in this video. Just know that we want to measure a real power here, not the apparent power or the reactive power. All right, so let's start. Let's zoom down and focus. I have those wires here are my AC switched. This is main switched by the foot switch. It's not the safest way to do it, but well, we're all adults. So the first test will be testing the voltage. So let's connect the meter. So the wire. I already messed up the wires. Let's connect it this way. Let's put it here. Maybe I will zoom down a little bit. Let's put this here. Let's put this one here. Let's take a look if my cat isn't near the desk. No, it's not. So let's connect the mains. It's off right now. Okay. Let's turn it on. Oh, there is some LPF here even. I didn't know. All right, and let's connect the power and hope it doesn't explode. Well, it's not perfect. Either of those meters is off by 2 volts. But 2 volts is 1%. So it's, I think we can say it's okay. Now for the current test. I will show you what I want to do. I have a transformer here. This is some random transformer. I already soldered a resistor here and 2 capacitors back to back. I will tell you why in a moment. This transformer has 17 volts when it's idle, and its short circuit current is about 11 amps. What I want to do, here is the transformer, the mains transformer. This is the primary, this is the secondary. This is the meter. Here is the current wire, live, neutral, live, neutral. Is it in focus? yeah, sort of. I want to connect a resistor here, this ammeter here, this one. Then I want to connect this meter and back to the transformer, and I want to compare the currents. I will pause while I connect it, so this video doesn't get longer than it has to be. One moment, please. Alright, I think it's connected. Let's connect the power. Is it really? Great. This one shows the current, this one doesn't. It happened to me before. I don't know why, but it does so sometimes. Now it works. Well, it's close enough, I think. You know what? Let's do one more thing. It's not wise, but and by the way, this power here, this is shown under the assumption that here, let me turn it off. Here on this transformer, let me focus. You have the primary voltage, because it measures the voltage, measures the current, hopefully measures the phase shift. Multiplies it and shows the result in watts. So of course here the voltage is lower, so the power is wrong. The power is way higher. I want to test it also without a resistor. Well, the current will be big. We will see how big, but maybe we'll be able to see. Okay, let's connect it. It's not very wise, but well, you can do it from time to time. It shows something close to what this meter shows, and by the way, it's falling because everything is heating up. So you shouldn't do it for a too long period of time. And now the reactive test. What I mean by the reactive test, I have two capacitors here. You know what? I will draw a schematic and show it to you once again. I already made a mess on my desk. This is crazy. It happens all the time. This is crazy. Another transformer, live, neutral, live to the meter, neutral to the meter. Here is the meter, and here is the current wire. And now we have a transformer, but instead of this resistor, we have two capacitors connected back to back, electrolytic capacitors. There are two capacitors, 100 micro. This good meter, let's call it a good meter. Device under test. Let's call it a device under test, and it goes back to the transformer. And what I want to see? Well, I want to see if, because previously the voltage multiplied by the current was roughly equal to the power that it showed. Now, what I expect? It will show some voltage, it will show the mains voltage, it will show some current, but it should show a much lower power. If it does so, then I think we can safely assume that it measures a true real power. Because, okay, I didn't want to explain it, but maybe I will. When you have voltage, right, here is the voltage. And when you have current, if it's in phase, well, it's something like this. It can be higher, lower, but it's in phase with voltage. Then you have a resistive load. But let's draw another. You cannot see it obviously. Let's draw another one. Here is the voltage. But for example, the current starts here. So the voltage, when the voltage is maximum, the current is minimum. Let's do it this way. Great. My drawing skills are are great, I know. But Well, the power is consumed when you have some voltage here, but the current flows backwards here, right? So actually the power flows back. So the power flows back and forth, but you cannot use this power. Okay, you know what? I don't know how to explain it better. If you're interested, look it up and you will know what I mean. Now let's just test it. Okay, I will pause and I will connect it. Okay, I switched it to milliamps, AC of course. And you know what? I don't know if those capacitors will be able to withstand the current. So I will do two things. I will use those protective glasses and I will make sure that my cat is not in the room. It's not in the room. Okay. Well, it has a possibility to explode. That's why I decrease the zoom so you can see it if it does. I don't think it will explode, but just to be safe. Is it connected? Yes, it is. All right, let's test it. There is some current. There is some power, which is way lower than I would expect from simply multiplying. You know what? Let's multiply it. 230 and yeah. All right, 229. Let's calculate it. Okay. The apparent power is this. Yeah? But the measured power here is only 5 watts. I think we can be sure that it's a real power. And no explosion. Well, sadly, no explosion. It would be more interesting, I think. Okay, so that's it. I will install this power meter, and I will be able to see the power draw of my house. Thanks for watching. No, it's out of focus. Thanks for watching.